All right, so we've made it to the last video of this standard, and we've been talking a lot about just finding solutions and finding factors so that we can get to the solution set of our polynomial equations. Well, now we're going to transfer that to the inequality idea, which is really the same thing up until the point where we write our solution. So once you find your x values for inequalities, we go to the number line and we test our intervals. So these questions or these examples that I'm going to give you today in this video are really just to remind you of how to test the intervals for our inequalities and compare them in the polynomial situation. So we'll try some more in class, but I've just got a couple here for us to work together. Alright, so this polynomial inequality is cubic. I know that because it has 3 x's. When I multiply this out, this would be an x cubed, but there's no need to multiply it out. Just keep in mind that it's a cubic, and that gives me the number of intervals that I will be looking at. So on my number line, I'm going to put the values using the zero product property. So I'm going to put on the number line a 0, I'm going to put a 2, and I'm going to put a -5. Because this is a solid circle, or I'm going to use a solid circle because it is inclusive. There's no denominator, so it's always inclusive or always exclusive. And then from this point, we're just going to be testing our intervals. So I'm going to choose something that's significantly less than -5, like -10. And I do that for an exaggeration purpose because I'm going to be just looking at these 3 as multipliers. So if I do a -10, I'm going to have a negative. If I put a -10 in this middle piece, it will also be a negative. And if I put a -10 in this piece, it will also be negative. Well, a negative times a negative times a negative is not going to be greater than 0. So the answer is nope for that group. Now if I put in a -1, again I'm going to go to each of the different factors and put in a -1. So -1 will give me a negative in the second piece, and a positive in the third piece. When I multiply a negative times a negative times a positive, it's a winner. This is greater than 0. Let's put in a +1. When I put in a +1, I have a positive. When you put a +1, you get a negative. When you put a +1 in the last piece, it's a positive. Well, this is not going to be greater than or equal to 0, so this piece is no-go. The last one, I can use a number, it doesn't matter, I can use a 50, I could use a 2.1, as long as I'm choosing a number greater than 2. So let's say I use a number 5. So I have a positive, I'll get a positive, and I'll get a positive. So of course this is going to be greater than or equal to 0. So in the end, the outcome is from -5, almost forgot my inclusive, to 0, union with 2 to positive infinity. Alright, let's move to the next one. Alright, here I didn't quite give it to you in the complete factored form, so you have to keep in mind that this is going to give me x equals positive and -3. This is going to give me x plus 1 equals 0 twice, so I get -1. I also have to remember that I have an open circle on my number line. So let's put all of these numbers there. -3 open, -1 open circle, and +3 open circle. You can't really put -1 twice, so I don't need to. I just have to keep in mind that it is a multiplicity, and that may come into play here. Let's take a look. So I'm going to choose a number less than -3. I'm going to choose -5. When I put in a -5 and I square it and then subtract 9, I get a positive value. When I put in a -3 or -5 to the second piece, I get a -2, but I square it. So that becomes positive. So a positive times a positive is not less than 0. -3 to -1, I'm going to choose -2 as my test point. When I put in a -2 here and square it, I get 4, but when I subtract 9, I have a negative. Well, if I'm doing anything to this piece, this is always going to be positive. But a negative times a positive is exactly what I was looking for. I'm going to use 0 for the next interval, so I'm going to test 0. When I put 0 in the first piece, I get a negative, and we just talked about the fact that the second piece will always be positive because I'm squaring the quantity anyways. So I have another winner. And then I'm going to test something bigger than 3, like 5. I'll use +5 again. So if I square it, subtract 9, I get a positive times another positive, and that's not good. So you might want to feel like you can go all the way from -3 up to +3, but see that -1 was exclusive, so I cannot include it in my interval, and I have to use another union. So -3 to -1, union -1 to +3, all exclusive. All right, I got one more example. Okay, so once again, I didn't give it to you in the complete factored form, so we'd have to factor it in order to put my numbers on my number line. If in the event that this was not factorable, I could use the quadratic formula, because the goal is to figure out what x equals. This one is factorable. It factors to x minus 5 and x minus 2. So these are the three numbers that I will use: -4, +5, and +2. Let's go to the number line. I have I have open circles on all of them. This is an exclusive. And let's test intervals. So I'm going to test a -5. You might want to test it in this one. It might be a little easier than dealing with that squared times a -7x kind of thing. So you might want to test it in the factored form. So testing a -5 gives me a negative, and a negative. That will not be greater than 0. Testing something between -4 and 2, I'm going to use 0. If I put a 0 in the first one, I get a positive, then I get a negative, and then I get a negative, but this actually works in my advantage. I want it to be greater than 0. Apparently it looks like I'm stealing something. I'll cancel that and deal with it later. I apologize about that. Alright, between 2 and 5, I choose a number 3. So that's a positive, a negative, and a positive. That does not work for me, so this one doesn't work. And then choosing something bigger than 5. I choose so if I use 10, I get a positive, and a positive. That's awesome. That's what I want. So this one gives me from -4 to 2, union 5 to positive infinity. Alright, so I think you're kind of getting the hang of this. We'll try a couple more in class, and great job.